today we're talking about integer properties, and this video is full of lots of notes and not too many examples. So what I really need is for you to make sure that all of your notes are complete and to really take advantage of the template that I have attached to Podium. So as we start the commutative property says A plus B equals C and B plus A equals C. And what the commutative property of addition tells us is that the order of the addends, or A and B, won't change the sum of the addition equation. So, for example, if you had 2 plus 5 is 7, and if you switch the order of those numbers and did 5 plus 2 is also 7. Another example would be 2 plus 3 equals 5, and then 3 plus 2 equals 5. We know that both of those equations are true, and just by changing the order of our addends, we did not change the sum of the equation. For multiplication, it's very similar. A times B equals C, and B times A equals C. Once again, this tells us the order of the factors will not affect the product of the equation. And you probably remember seeing a lot of worksheets back in elementary school when you did lots and lots of multiplication examples, and you saw 9 times 5, and then a couple examples later it was 5 times 9. And one of the tricks was to recognize that those products would be the same number. So an example could be 2 times 3 equals 6, and then of course 3 times 2 equals 6. The associative property discusses more along the lines of what numbers or what pieces of the equation are associated with one another, how they're grouped together. So it has to do with parentheses. And the rule including variables is parenthesis A plus B, close parenthesis, plus C equals D. And then when you rewrite that, the order of the terms does not switch, it's just the position of the parentheses that is shifted. So now we have A plus parenthesis, B plus C, close parenthesis equals D. And it says the association or grouping of the addends will not affect the sum. Or will not change the sum. We can see an example here. If I had 2 plus 3 inside my parentheses, that means I do that piece first, that's 5, plus 4 will give me 9. But if I had 2 plus 3 plus 4 in the parentheses, I do that piece first, 3 plus 4 is 7, and then plus my outside 2 is still 9. Similar to the commutative property, the associative property for multiplication is the same as addition. It's just using multiplication. So A times B times C equals D, A times B times C equals D, with, of course, the position of the parentheses changing. And once again, this is really about the association or grouping of the, instead of addends, we're talking about factors, and how this will not change or not affect the product or the solution to the multiplication equation. An example is 2 times 3 times 4 is equal to 2 times 3 is 6, times 4 is 24. And then of course 2 times 3 times 4, 3 times 4 being 12 times 2 equals 24. Moving on to integer properties, or a few more integer properties. With the distributive property, we're looking at numbers that when a number is being multiplied by a set of numbers within parentheses. So as you can see, the example over here is 2, and any number placed directly next to parentheses does imply multiplication. So 2 times the quantity 5 plus 7. And whenever this occurs, the distributive property tells us that the number on the outside must be multiplied to each term inside the parentheses. So I like to distribute my 2 or attach it to each term inside the parentheses so I remember what I'm doing. And when I rewrite the equation, I can write it as 2 times 5 plus 2 times 7. When I do the multiplication, I get 10 plus 14 is equal to 24. Now note that if you did 5 plus 7, that would be 12. Plus 2 times 2 would still be 24. This is not always the case, and that's why we do have the distributive property. So moving on to exponents, x to the y power basically means the number x is multiplied by itself y times. This is a very interesting concept. Sometimes people like to say, for example, x raised to the y would just be written as x times y, but that's incorrect. You have to multiply the x number as many times as it says in the exponent. So first example, 4 squared is 4 times 4, if there's 2 4s. 3 to the 4th power is 3 times 3 times 3 times 3, and that's because we need 4 3's. And 2 to the 5th power is 2 times 2 times 2 times 2 times 2. Integer operations. Now, your best bet with this set of notes specifically is maybe to go to the end of this slide when this entire table is filled in and copy down everything that's there and then go back and listen. Or maybe listen through once completely, pause the presentation, go back, take your notes, and then listen through again. These are very complicated properties. So I'm going to use a plus sign to represent a positive number and a minus sign to represent a negative number. And that could make it a little more confusing. Just think that we're adding, subtracting, multiplying, dividing. So the first slide that I filled in was addition. And if I have a positive number plus another positive number, my answer is going to be a positive number. If I have a negative number plus a negative number, my answer is going to be a negative number. When I get to subtraction, it's going to be a little different, so I do want to write all the possibilities. I have same signs in this box, positive minus positive, negative minus negative. The red L's that I'm